second type of water is purified water USP. This type of water, when evaporated to dryness, it must not yield more than 0.001% of residue, which is about 1 milligram of solid per 1 milliliter of water. That means it is 10% as much as dissolved solid as that of the tap water. Purified water USP is intended for use in the preparation of aqueous dosage form except those intended for parenteral administration or injections. Why we can use this type of water for the preparation of aqueous dosage form unlike the tap water? Why? Because it is purified. It contains less amount of the total solid than that of the drinking water. Therefore, there will be any possible interaction or less possible interaction between the solids and the added medicinal agents. But it cannot be used for parenteral administration. Why? Because it is not pyrogen free. This type of water is only sterilized, but it is not pyrogen free. This type of water can be obtained by 3 methods: distillation method, ion exchange method, and reverse osmosis. In distillation method, the first 10 to 20% of distilled water should be discarded. Also, the last 10% should be discarded too. Why? The first 10 to 20% of distilled water should be discarded to avoid the presence of any volatile material from the urban drinking water when it first entered the distillator. Also, the last 10% should be discarded because evaporation to dryness results in the decomposition of the resulting solids into a volatile material that may contaminate the collected distilled water. Therefore, 10% of the last 10% of the water of the last 10% of the collecting of the last 10% of the present water in the apparatus should not be evaporated to dryness and distilled. Deionization method. In this method, we note that it is preferred over distillation method because it eliminates the need of heat. Also, it eliminates the costly and troublesome maintenance that is required for the distillator. The process passes water through column composed of synthetic water-insoluble polymerized high molecular weight resin that is of 2 types. First, there is the cation or acid exchanger. Second, we have the anion or base exchange resin. In first type, for the first type, which is the cation or acid exchangers, we permit the exchange of cations in solution with hydrogen ion from the resin. In the second type, which is anion or base exchange resin, it permits the removal of anions. This can be explained by the following equations. We assume that M positive is the metal or cation, for example, sodium ion, and X negative is the anion, for example, chloride ion. Hydrogen will be in the first column, which is the acid exchanger. Hydrogen that is present in the resin is replaced by the cation, which is present in water. So the resulting water will contain hydrogen ion in addition to the anion. In case of the anion or the base exchange resin, we can note that the resin that is bound with NH2 has the ability to remove hydrogen ion and the anion that is present in water, and so the resulting water will be pure. This type of water can be used for what? For the prescriptions that called for distilled water. The other type of water is water for injection USP. This water is purified by distillation or by reverse osmosis as that of the purified water. It differs from purified water in that it is pyrogen-free. It is the same as that of purified. It is the same as a purified water for the presence of the total solid. Also, it contains the same amount of total solid that is present in purified water, but it differs from purified water in that it should be pyrogen-free. This type of water, unlike the purified water, unlike the next type of water, which is sterile water for injection, this type of water is not required to be sterile. It must be pyrogen-free only. That means water for injection USP differ from the previous type of water, which is the purified water, in that it should be pyrogen-free, but it is the same as that of a purified water for the present amount of the total solid. Also, this type of water, which is water for injection, is unlike the next type that I will discuss it for you, which is sterile water for injection, in that it must not be sterile. It is only needed to be pyrogen-free. Why? Because this water is intended to be used in manufacture of injectable products to be sterile or sterilized after preparation. That means we can prepare this water in a large amount kept in a certain tanks and then use it for the preparation of the injectable products to be sterilized after preparation. This type of water only pyrogen-free and has limited amount of solids, but it is not needed to be sterilized, as I mentioned, because it is intended to be used in the manufacture of injectable products to be sterilized after preparation. Also, it contains no added substances, for example, antimicrobial agents. Water for injection is intended to be distilled, sterilized, and used within 24 hours. That means this water should be used for small period of time after preparation. The water should be collected in a sterile and pyrogen-free containers. The containers should be glass or glass-lined. If water to be stored for a month, That means it is not to be used directly after preparation. It should be kept in a special tanks containing UV lamp. How can pyrogen test be performed? You know that this type of water, which is water for injection, the first requirement of this water is to be pyrogen free. It may or may not be sterilized. So, pyrogen test is necessary for this type of water to be performed. This pyrogen test can be achieved by adding 900 mg of pyrogen-free NaCl for each 100 ml of water, followed by injection into animals. If there is no signs of disease, so it is pyrogen-free. For sterilization, if there is a need to be sterilized after preparation, autoclave is used. If autoclave is not available, distilled water can be sterilized by boiling for at least 60 minutes in a flask stoppered with a block of purified non-absorbent cotton covered with gauze or any other non-absorbent papers. Then it is allowed to cool without removing the stopper. The other type of water is sterile water for injection. From its name, it is sterile. That means it differs from the previous type of water, as I mentioned, in that it is necessary to be sterilized. In addition to that, it must be pyrogen-free, like the previous type of water, which is water for injection, and also contain limited amount of water as that of purified water. So the first requirements for this type of water is that it is sterilized. We can see that this type of water is packaged in a single dose container, not larger than 1 liter. Why in a single dose containers? Because it is only for one use. Why it is only for one use? Because it contains no added substances like antimicrobial agents. So it is only for one use. Therefore, it is packaged in a single dose container, not larger than 1 liter. For what we can use this 1 liter? You can note that this 1 liter containers is used for reconstitution of multiple antibiotics at the same time. As with water for injection, it must be pyrogen-free. Also, it may not contain any antimicrobial agent or other added substances. Therefore, as I mentioned before, it should be kept in a single dose containers. This water may contain slightly more total solids than water for injection. Why? Because of the leaking of solids from the glass-lined tanks during sterilization. The 1 liter bottles cannot be administered intravenously. Why it cannot be administered intravenously? Because it has no tonicity. The other or the final type of water is bacteriostatic water for injection, USP. This type of water, from its name, it contains bacteriostatic agent. It is unlike the previous type of water, which is sterile water for injection, which should be not contain any added materials or antimicrobial agents. So it is only for single use. But this type of water, which is bacteriostatic water for injection, contains antimicrobial agent, therefore it can be used for multiple. It can be intended for multiple use. It is sterile water for injection containing one or more suitable antimicrobial agents. It is packaged in pre-filled syringes or vials containing not more than 30 milliliters of water. It is important to note that the volume of this type of water in a single package, in a vial, should not be more than 30 milliliters. And you can, later you can note the reason. Theoretically, presence of the bacteriostatic agent gives the flexibility for multiple dose vials. That means if one person inadvertently contaminate the bacteriostatic water for injection during his preparation of any type of injection, he can use it again for another injection because of the present bacteriostatic agent will kill any possible contaminated microorganism, any possible microorganism that contaminate the water. It can be used only in parenterals that are administered in a small volume. Why? As I mentioned before, it must not use in more than, or it should not be packaged in more than 30 milliliter vials. Why? Perhaps because of the toxic effect of the antimicrobial agent that will enter the bloodstream. If more than 5 milliliter of solvent is required, then sterile water for injection rather than bacteriostatic water for injection is preferred because of the present amount of the antimicrobial agents may have a toxic effect when it is above the required limited or the required limits for bacteriostatic agent in the bloodstream. You can see that USP labeling requirement demand that the label state not for use in units. USP labeling requirements demand that the label state not for use in units. Why? Because the resulting problems that encountered within units and toxicity of the bacteriostatic agents that, for example, benzyl alcohol. This toxicity results from the high cumulative amounts of benzyl alcohol and the limited detoxification capacity of a unit liver. Therefore, this type of water should be labeled with the requirements that it is not used for unit. Also, the percentage of the antimicrobial agent should also be written or should be labeled in this type of water so as to avoid chemical compatibility that may occur between the antimicrobial agents and the present medicinal agent. Thank you.